program, you can't really get to it. Well, unless some programmer gives you access or provides you the access, you can't get to the data. So I think until we solve the self-service problem, Hadoop won't get wide enterprise adoption like it did at Google. Like they had to solve at Google to get basically have the people living in the lake and basically constantly working with the data.
So actually, as somebody usually works on the analytics side, the self-service is just a great thing, because in the database scale, usually if you run a very interesting analytic query, it's going to be a table scan because it's not something they designed for, and the DBA is going to find you. And because you're going against a system of record, you're delaying other jobs, but usually a data lake is over-provisioned both in CPU capacity, disk capacity, and stored data capacity. So early on in the history of the project, you can do quite a lot. You can basically self-appropriate data, and you can also try methods that normally would not be allowed in the database. And I think it is really a great thing. Though I think we might be in the Wild West freedom style of it right now, because I think as we get into more security and personally identifiable information and confidential information, the everything's in Hadoop model is failing. I know there's tools that are addressing this, but I think we're people are kind of delaying applying them right now.
So if you're a data scientist, take advantage of the Wild West. It won't last forever. And
Yes.
we're here to talk about it. And I would like to understand, we have this elephant in the room, but it's not Hadoop, it's metadata. And it's data quality. With new quality of data, we get, or in terms of, we get unstructured data. We get data from different sources. We collect what we were not able to collect before, and therefore we don't know how to really process it effectively. So how do you define data quality, and what is new in this new data quality for big data compared to traditional data quality of profiling, matching, and so on, and how do you approach it? It's a big question, but I think that's why we're here.
Okay, I guess I got voted to go first. So, I mean, to some degree, Waterline was the product we built to solve some of those problems, right? To inventory the data, to provide insight into the quality. I think the approach to quality is very different from a data warehouse. Data warehouse, traditionally one size fits all, right? We have an ETL job, if we have garbage in our number field, we throw it out. Or we flag the records, but we really don't have multiple versions of the truth. If you're doing data science, that garbage might be very valuable. So data scientists want the raw version of the data. They want to understand what's going on inside, but they want to have control over what happens to it. And then other people want to be able to find what they did and either use it or not use it because they want to use it differently. So I think, again, it goes back to the self-service model where people naturally want to be able to reuse, but they don't want to be told what they have to use. And we need to find the balance between the two and go from this one version of quality and truth to, okay, here's your version, I want to put average income for the missing incomes, and you want to take out all the rows where income is missing. Both are legitimate, there should be one way to do it.
So to me, it's not the thing that big data is not problematic with respect to quality because it's big. And by that I mean there are many records in it. It's because it's usually very messy. It comes without well-defined schema. It's very denormalized, so it's impossible to govern. And it doesn't come with interfaces that impose semantics. So everybody kind of has to figure it out from scratch. Adding to that is the fact that it's generated by numerous applications and processes and dumped into this lake that we're talking about that nobody really can control. There's no data administrator that can keep up with this. So you have to give up and you have to hope that it's going to work. So this is a major problem. It needs to be addressed. If it's not addressed, it is very likely that this data lake idea will probably fail. And it's going to be basically for the very few that know how to deal with this. Usually, controls like security and governance trump features all the time. And also, if we make it so difficult to use that only very few people can use it, it's going to become a boutique solution. That's not what we want. We need to fix this problem.
I'm pretty excited about data quality. And so the traditional definitions deal mostly with provenance of data, density, coverage, annotations, that if you don't know where the data came from, in the traditional view, it didn't exist. And again, I work mostly as a data scientist and analyst, so most of the data I've seen has been denormalized for analysis. The analyst fantasizes about having everything in one row ready to go. And you don't even hear discussions of star schemas and higher normal forms in Hadoop. I mean, you do a little, but because many of the older Hadoop tools have very weak join technology, a lot of data scientists work in terms of transformations and basically make weird copies of all the data. And I think that's also going to kill a data lake, that you may have the size of the lake is proportional to the original size times how many people touched it. And then the very last thing that excites me a lot is because data lakes, to my mind, we were talking about operational data, but to my mind, they're always driving analytics. So in addition to the data having the usual correct semantic annotations and properties, which Hadoop often doesn't even have schemas, but in addition to that, it has to have statistical properties. So if a data process is collecting records on people that turned into successful sales, you need the implicit guarantee it's collecting records at a similar rate for people that didn't convert, because you're going to build machine learning models, so you need distributional properties, your data to be true, in addition to individual rows and fields being valid. And that causes a lot of problems that, you may have a logging system go offline for a long period, and now it's contaminating data in a weird way. Maybe it went offline during Christmas, so not just a random time, but during where 70% of your company's sales are. And these are, because you're always doing analytics, to my mind, you have a lot higher requirement. And I've been talking the microphone.
So one of the interesting challenges with data lake is we are getting data from different silos and then building relationship in the data lake as we understand the data. Now, one of the key problems there is how do you make sure that that data is consistent, right, within itself. It's a really hard challenge, and if you see traditionally when the data was brought in to the data lake, that is when the quality, quality is measured and the data is, declared as whether it's, good data or bad data. But with, a lot of data just being ingested into data lake, processed later, and also, different parts of the data getting processed, at a later point, and then you could have an ETL job that refines it, and then, later it gets consumed by somebody else because of the service nature of data lake. The inconsistency in data, it could be discovered much later. The problem with that is once, somebody can flag that the data quality is bad, there are a couple of things that need to happen. There could be multiple data sets that could be derived off of the source data that resulted in this, right? So one key problem with making sure that system can control the quality is to capture lineage, right? So you need to understand which was the source of this data and then what other data has been derived out of it, right? What other data sets have been derived out of it. That becomes a very key problem, and that's one of the reasons why in Apache Falcon project we started capturing lineage right up front, so that given a data set you can figure out who contributed, what data sets participated, and what kind of processing was done to generate this data set, and what other downstream data sets have consumed this. Right? So that becomes a very critical problem in data lake.
I'm glad that you mentioned some solutions, and many people are here to learn about solutions and what can you do? What can you do now versus maybe you should wait if you have time and there will be something greater in the future? I would like you to share those best practices if possible.
Well, from our perspective at Waterline, you should build a data inventory, and you should do it as early as possible, because if you wait until you have millions of files, it's going to take longer to dig through the mess than to grow it, in an automated fashion. And the product we built is automatically discovers lineage, automatically looks for sensitive data, because I think as John Dimitri mentioned, governance becomes an issue, right? If you open it up to everybody, you want to make sure there's nothing inappropriate in there. So you have to find it without having to look manually at each file. So I think solutions like that Falcon is a good solution where processing gets captured as lineage, and you can tell where the file is coming from. And then if there's manual work or if there's some other work that's not captured, we can add to it using Waterline discovery process. I mean, there is a lot of work being done. Traditional vendors do have tools for profiling and traditional data quality and capabilities. I think that the original problem of you have lots of silos, you still have the same quality problems, right? You still have the same integration problems, the same problems of not knowing what's where. But the data lake, they become easier because everything is at least in one place. I mean, you haven't figured out what's where, but at least you got in one place, so now you can use one set of tools to figure it out, as opposed to going to all these different systems and trying to use their APIs and try to understand their metadata.
So Svetlana had warned us that she's going to ask this question. So I tried to think about it and be as prescriptive as possible without actually offering how to do it. I think I can list things that need to be done. First, and maybe in order of priority, Africa. The first is about schema. The data has to get schema, has to get semantics, and it has to be very easy to understand, so that even non-technical people can get it. Second, data access control. Data access and data sensitivity should be very clear. If a file contains a credit card number in one of its fields, you need to know. People need to know, and you need to know who has access to it, and it has to be very transparent. Third, data lineage that you mentioned. It's very important to keep track of backwards and forwards lineage. If I know that a file is derived from some other file, if I know the forward lineage, I know how to fix a problem that I found in my base data set, and I can go and fix it everywhere. Or I know how to wipe out data if I'm told that some piece of data needs to be obliterated from everywhere. I know how to find it everywhere and delete it. The backwards is also very important. If I know what a piece of data is derived from, I can choose better of what data set to work with. Plus, the system can do cleanup, like deleting duplicate data sets or deleting data sets that are easily rederivable. So we are at 4 now. So fifth, data usage. It would be great if I know what a data set is being used by whom and for what purpose. This is going to inform me as a new user whether to use it or not and how to use it. And sixth, and that's actually the most technical aspect of this, is that it would be great if data comes with statistics about its size, cardinality, partition sizes, and stuff like that, so that queries against this data can be optimized. Otherwise, queries will be always inefficient and always consume a lot of resources. So these are my 6 points.
Thank you so much. John?
No, that's good.
Yeah, so one thing that you must have is a set of tools that can capture lineage, right? I believe quality in a data lake is not a one-time event, right? It continuously happens, right? As people look at more data, the parts of the data that never, was looked at, as you start, running those kind of programs, you will start finding different quality issues. So quality is not a one-time event. So the system that you're using must make sure that there is lineage for the purposes, so that you can go back and fix issues. The other key thing that we are also seeing is a lot of times when the data gets onto data lake, it also gets resent because there were some fixes that were made to the data. So your system must support an ability to get this kind of data and build the whole pipeline again, right? When the data has gotten restated, right? That becomes a very key. That becomes a key feature. Then the third thing that a system must have is, as these discrepancies are found, one way is to just overwrite the data, but you also want to keep a lineage of different data sets as they were fixed, right? You keep the older version. That way, you can go back and relook at how the data quality has changed, where the data quality issues are.
Actually, just to emphasize one of your points that's really exciting to me, when we're teaching data science, we try to teach the data scientists that they're always at best on their penultimate analysis, using that word correctly, that they're going to have to rerun. And it's actually something that was very hard in the early Hadoops, like more rows coming in was always a problem, let alone replacing rows, just set. It was so batch, it was hard to deal with data growing, and people used to just say, well, I'm going to lock onto this data set from January, and I'm going to use it for the rest of the year to build models, because I don't want to deal with any more rows and cleaning them. And it's obviously, things are much more flowy and data flow now, but it's moving over time is very hard, and repetition is very hard.
Yeah, so in that regard, now data is not just data that just came in, it must have version number. And then also the processing that you're doing on the data, those processes must also have version numbers, because you can either restate the data or fix a bug in your processing. Both of those are very important in a system if you want to maintain good data quality.
Actually, that lineage of results is incredibly important. One of the high points of my career is we deployed a product classifier at shopping.com, which would automatically place items into the 150 entry product catalog. Day I deployed it, the VP of engineering comes to me and says, you just put a shoe in thumb drives. And and what it was, thanks to the lineage annotations, I could say, no, this shoe's been in thumb drives for a month. I didn't put it there. My process didn't touch the shoe. And being able to survive the blame storming is something I really like.
So all the discussion about changes remind me of another issue, schema evolution, because a lot of data is going in, and because frequently nobody is even looking at it for a while. You might look at it and then go away for 6 months to look at it again, or not even look at it for years. Keeping track of schema evolution is very important, and knowing that that this is the schema that was there at the beginning, and the missing fields are not zeros, right? They really just weren't there to begin with. They might be anything. And it also affects your data quality and cleansing and preparation for data science, because if it wasn't there, you might put an average, and if it was there, you might put a zero. And so all this information needs to be tracked and captured.
So fascinating. It's another dimension. So we see the data not in its static form, but in its dynamic form. So I don't want to really hold people from asking questions. And what I suggested, we will make a break from asking questions. If anybody has questions, please come over and ask our esteemed panel.
Hello, I'm Nick Boller from Data Virtuality. Thank you very much for your insights and for your interesting discussion. My question with respect to data lakes and data governance is, well, this term data lakes is kind of often used as not in a singular, but lakes, and it kind of reminds me of data silos, which is usually has some bad connotations. So data silos, bad things which need to be connected. So, and also speaking about governance and data lakes, it's kind of something that makes me think about, okay, that I will probably have to not to govern the data in one data lake, but in many data lakes in the organization. Maybe one of them will be Hadoop, another one will be Spark, and the third one will be Amazon Redshift running somewhere. I mean, what about governing the data on this kind of larger perspective? Or do you think will it really be possible to really have one big homogeneous, not very clean, but still one data lake in the organization? Or will there be a large need to govern this on kind of larger scale with integration of different data lakes. So how will this future look like?
So what we're seeing, talking to a lot of large companies, they have multiple lakes. You're absolutely right. And some of them are raw, right? So business got tired of IT, they just went on Amazon and created a lake, or they bought their own cluster and got it installed. And what people are asking us to do is provide a single catalog across all the lakes. They actually don't want to integrate the data necessarily, because the data that goes into each lake is project or, division specific or business unit specific. But what they want to be able to do is find it across all the lakes and provision it, to their lake if necessary. So I think it's going to add to the mess, not necessarily reduce it, but just like very few people have a single huge metadata warehouse, most of them have multiple mega warehouses. I think lakes are going to follow similar evolution.
So what is the special requirement for data lake, especially on private cloud side? Did you get my question?
Did you want to answer?
No, what is the special requirement for data lake on cloud computing side, especially on private cloud?
So, there is, data lake is nothing special other than, what are you doing with your infrastructure in terms of, how you are bringing data into one single place so that you can, sort of build relationship, together of all this data that you're storing, that used to be in different silos, right? So now that you have all the data in one place, you need things where it should be easy to acquire the data, right? So that you can put it in data lake and in a predictable manner, process it, refine it, and store it, and make it available to your users, right? So that becomes one key element, and with that comes governance, right? You are putting all kinds of data from different organizations into a single place. So you need clear governance in terms of who can access what, right? Who can access how much, right? What needs to be maybe encrypted and allowed only for certain organizations, what is readable by everybody, like credit card, social security number, those kind of examples. So governance becomes a very important thing. And then we talked about, with so much data available, your different business units must be able to access the data in a self-service manner. So self-service is an important aspect of data lake. So if you're not doing anything in terms of how you're setting up the cluster, these are all practices around the cluster you already have, right? The infrastructure you already have. So self-service becomes very important, to which, cataloging and data discovery, they become really important in data lake, because now you have different organizations, different business units data all in one place.
I think my question is actually more focused therefore on the capacity planning in terms of cost reduction.
Capacity planning,
Whether to reduce your capex as well as OpEx.
So I'm going to answer this because I'm not an engineer anymore, but so the question is CapEx and capacity planning and stuff like that. So from my point of view, a lot of these projects actually have positive ROI, so they can afford to spend on machines. And so I know it's a little inconsistent with store the data first and use it later, but usually I've seen less capacity planning and more just recruiting money as you go.
Talking from experience at Google, we have never had to talk twice about justifying the cost of a data lake, no matter how big it is, because all you need is one win, and you get basically the return back, and more, much more. Going back to the data governance, I think that's very important, because that's going to make or break a data lake. Lineage, access control, all of the data usage, auditability, all of these things have to be in place. If they are not, if you take the cavalier approach and say, okay, we'll figure all these things later, something very bad will happen. A bad reputation will come along with the data lake, and then we will end up basically with this concept that sounds very cool and very interesting right now, will end up getting destroyed. So I think it needs to be accompanied by these other things that we said earlier in order to be successful. Right now, it's just cool, just interesting.
I have a question. I come from the financial sector, and many times in our organization, business lines are federated and they run their business in a federated model for legal reasons. And so infrastructure in the past has been federated. You had databases that supported specific business lines. So now with Hadoop, there's an opportunity for us to have a central infrastructure but still support federated business needs. But that puts heavy restrictions on security and governance. One is the security access controls, but also from a governance standpoint, because my business lines were federated, a data element was named the same across business lines, but they actually mean completely different things. How is that addressed from a data governance standpoint? Cataloging helps, but you're getting really different data sets together, but
Yeah, that's very common. So what we get to support is let people tag and put their local meaning, so effectively called synonymy or crowdsourced ontology, so the analyst from one place will, even though it's called food, they'll say, oh, that's really bar for me. And the other person might call it something else. And both are legitimate. So both will leave and be from one business unit will look for food, the other business unit will look for bar and find the same data element. Or find different data elements with the same name because they're going to be qualified differently. So you're absolutely right. This was, again, a big, I spent about 10 years of my life on the space of building ontologies, and you could never build one because it was so different. There wasn't one meaning to anything. And the trick is, I think, to crowdsource the meaning and let people express it the way they want to express it, and provide the search engine so they can find it. And on the back end, you have the governance to let them organize it.
So I guess transparency becomes the key, understanding the process.
Transparency and also focus on content creation, not management, because a lot of companies focus on, let's be very careful who can, for example, create a definition. And so they have very few definitions, and the ones they have nobody wants to use. Instead, let everybody create definitions and organize them later, because you know how they're used on the back.
how do you make sure data science doesn't get data science Wild West, right? Because we need to be aware of what the definitions are.
Well, if you know who tagged and what they tagged, right, you'll be able to track people on top of them. Again, depends. So traditionally, the way it works, right, you ask somebody, your data scientist, I'm sure John can talk to this, you ask people, who knows about this, right? And somebody will point you to somebody will point to somebody, you'll find the subject matter expert. That person will be able to explain to you at least what they know. Well, if that person, subject matter expert, they're working with this data all the time. If they annotate and tag the data they're working with, you'll be able to find without having to go through 50 people to find the right expert. And you'll see who tagged it. So again, you'll be able to call this person directly and say, hey, I'm working with your file. You know, this is called who, is that really what I'm looking for? Or should I look for something else? It kind of short circuits the whole long, elaborate manual discovery process.
Yeah, the point I made earlier about being able to go to a data set and see who else is using it, how, not only so that you can learn how to use it, but also so that you can verify your semantics. And the trick here is that you can do that when you have 100 tables or 100 files, or maybe 1,000 or maybe 10,000. What if it is millions or billions? And that's where technology comes in. That's where automation comes in. That's where the problem is not just process, but it's also technology and sophisticated technology. But the problem you mentioned, we even have at Google, there's very often questions about how do I join these two data sets, what customer ID here, customer ID there, are they really the same? Or revenue here and revenue that's here, can I actually subtract the two, or they have different units? Or so it's this is a major issue, and it has to be solved.
So I've worked with content management for a long time, and I know that from an enterprise sense, problem that she raised, which is, sometimes you have duplicate data sets, you just don't know that. And then, do you have, any of you have any of these stories where using the data lake and doing this kind of assessment to say, I'm calling it flu, and it's the same as your poo or whatever, and in some cases they're configured to driving major change, major cost savings and optimizations in terms of just eliminating needless data collection and this kind of in the enterprise, not just for predictive analytics, but just in general.
Well, the data lineage is what you really need to do that. You need to have a system that collects the information about what derives from what, and then have a system that can use this information to be able to derive from what is duplicate and what can be eliminated, or what is wrong if something is wrong in space. I don't know if that was your question.
I know there are companies that spend a lot of time and effort just reducing their data footprint in some ways, so there's redundancy. So to me, this seems like a good use case of looking at that kind of analysis to reverse engineer, therefore I should sunset this piece or that piece.
Yeah, the question was for those of you who couldn't hear us, if there's so much redundancy in the enterprise of data, is this a good opportunity to sunset some data, identify the redundancy and subset some data? And we are working with a number of large banks and manufacturers who are actually using data lake just for that. What they want to do is put everything in there and then look for commonality and curate and say, oh, this is the good data set to use for this type of data. On the flip side, a lot of people we're talking to, like one investment bank told us, they measured it and there's 2.7 times the data they put in the lake without any more information. So people just make a lot of copies and play with it, and a lot of the data is just temporary. A lot of data science is experiments, and a lot of them fail. And for example, if you do search, you really want to find somebody's failed experiment. You want to know the lineage, and you want to know, oh, this is the good file. This is not the junk that never succeeded, right? Which is not easy to do, right? If you don't know.
Last question.
Last question here.
Hi, this is Niru from ADT. My question is about data quality. So how do you ensure, I know it's a repeated process, it's going to be, it's a closed loop control system, that's what I could say, as data quality itself. But how do you say that data has been delivered from the source to the data lake itself, where you are maintaining everything, and how do you ensure that whatever is there in the source is already there in the data lake, and the data scientist or the person who's actually working on the data tells that this is a very good data? How do you ensure that? Because this is what almost all the systems require. I had worked even in Walmart or even in AT&T, so they have complaints about what the data is going to be, or is there a problem with the data? We have different sources of data in all the places. So, question to everyone. So,
I've actually had some pretty negative experiences in data quality. So there's a sort of a thing in programming that, test-driven development, that your neighbor should never be the first one to call your code. But in these self-service data systems, you often may be the first person using a column, which, if we again apply the software engineering principle, it means the column is by definition wrong. You're the one debugging it. And my group has found, like in a lot of places, you ensure quality by simple statements like, well, this column is writing bonuses to salespeople, so therefore the business would have died if this column is wrong. But then when you dig around, you find out the column is so valuable there's an intern correcting it on the way out in the system you don't know about. So the original system, no system in the thing may have the correct column. It's just there's an intern that's actually correcting it because it's so valuable. So other than closing the loop, showing people predictions you're making on the data, showing them the column, showing their CEO a pie chart of where the sales are in the company relative to what's in the system of record versus what's in that, it's very hard to ensure data quality. Now, ensuring fidelity is easy. like, which was another part of your question, if the data is correct in one system, it's fairly easy to make it correct in others. But if it's wrong to begin with, it is a bit of a problem.
Yeah, I've seen people before writing code to do assertions against the data. You know things that are invariants, and you try to certify them periodically so that you have some kind of quality control by probably getting some kind of fingerprint on the data or some kind of aggregate that will indicate whether something is off. Whether that's over time, or that's comparing one data set with another, whether that's comparing one data set against its source, all of these things. But one way or another, trustworthiness and freshness, that's also very, very important. Freshness is actually equally important. It's very easy to be fooled by data that's stale. Even though it's correct, it's stale. It was for last year. Nobody actually, it's not clear, and you start using it, and you get fooled. You draw their own conclusions. So trustworthiness and freshness have to be certified.
Yeah, having been on data quality business for a long, 20 years at companies like IBM and Informatica and so on, I haven't seen a company with clean data, honestly. And you know, it's actually horrifying how bad most of the data is in financial service companies and some of the largest companies. And I think realistically, what people are doing, they're focusing on a few key data values and trying to at least make sure those are correct. And beyond that, you know, it's an exercise left to the user. And what's interesting about data science versus, for example, data warehousing in BI, if you're doing BI, you get a report and it says, look, we sold last month 5 times more in Finland than in the United States. Say, oh yeah, looks like a problem. So you start digging for data, right? If you get customer segmentation and you end up with a shoe in context, yeah, you